Today we will be learning about comparison of planet distances in the solar system from the Sun. Let's begin. When it comes to measuring distances in space, units of measurement on Earth are too small. The universe is enormous. Look at this example. The average distance between the Earth and Sun is approximately 150 million kilometers. Next, in our Milky Way galaxy, there are a large number of stars. The nearest star to our Sun is known as Alpha Centauri. The distance between the Sun and Alpha Centauri is 4,068 billion kilometers. If you look at these numbers, it is very large, and representing them in kilometers is not convenient. So today we will be learning about astronomical units and light years. We know that our Earth revolves around the Sun. The Earth's path is called an orbit. Earth's orbit is not a perfect circle. It is elliptical or slightly oval-shaped. This means there is one point in the orbit where Earth is farthest from the Sun, and another where Earth is closest to the Sun. When the Sun and Earth are farthest apart, this position is called aphelion. In this position, distance between Sun and Earth is around 150 to 1,100,000 kilometers. Then, at perihelion position, distance between Sun and Earth is the smallest, which is 14,710,000 kilometers. The average distance between Sun and Earth can be calculated by taking average distance of perihelion and aphelion positions divided by 2. You will get approximately 150 million kilometers. This distance is called astronomical unit. In short, 1 AU. To make it easier, 1 AU is equal to 1.5 times 10 to the power of 8 kilometers. Astronomical units are used to measure the distances within the solar system. For example, distances between the Sun and planets. Next, light years. When leaving the solar system and looking at objects that are very far away like stars, the AU is too small for scientists' needs. So, astronomers use light years to measure distance traveled by light in 1 year. Remember, it is the distance and not time. In general, the formula of distance is speed multiplied by time. The speed of light is 300,000 kilometers per second, while the time in 1 year is 31,540,000 seconds. You can get that by multiplying 365 days times 24 hours times 60 minutes times 60 seconds. So in 1 year there is approximately 31,540,000 seconds. Now that you have the speed and time, calculate the distance by multiplying the speed 300,000 with the time 31,540,000. Then you get this big number. To make it easier, 1 light year is equivalent to 9.5 times 10 to the power of 12 kilometers. Now let's learn how to convert units between astronomical unit, light years and kilometers. The formula to calculate distance in astronomical unit is distance in kilometers divided by 1.5 times 10 to the power of 8. Next, to calculate distance in LY, distance in kilometers must be divided by 9.5 times 10 to the power of 12. Here is an example. Jupiter is the 5th planet in the solar system, which is 7.78 times 10 to the power of 8 kilometers from the Sun. A. Calculate its distance in AU. B. Calculate its distance in LY. To calculate its distance in AU, take the distance in kilometers, which is 7.78 times 10 to the power of 8, and divide it by 1.5 times 10 to the power of 8. The answer is 5.2 AU. This is how you calculate it on a calculator. Press 7.78 exp8 divided by 1.5 exp8. When you get the answer, round it off to the nearest tenths. You will get 5.2 AU. Now for B, take the distance in kilometers again, which is 7.78 times 10 to the power of 8 divided by 9.5 times 10 to the power of 12. When using the calculator, press 7.78 exp8 divided by 9.5. exp12. you will get this answer. Then, you have to round it off to the nearest hundredths. The answer is 8.22 times 10 power negative 5. Now, if Mars is 2.28 times 10 to the power of 8 kilometers from the Sun, how far is it in astronomical unit and light years? Pause the video and try to calculate. Use the formula given. Alright, did you get the answer? Distance of Mars from the Sun is 1.5 to AU. And distance in light years is 2.41 times 10 to the power of negative 5. If you want, you can pause the video and try to fill in the table. The answers will be in the description box below. Let's do a quick recap by answering this quiz. Question number 1. Light years are a measure of A. Speed. B. Time. C. Distance. D. Light. What is the answer? Yes, the answer is C. Distance. Next, question number 2. The average distance between the Earth and the Sun is the answer is the astronomical unit. Moving on, which of the following distances would we use light years, and not astronomical units? Mercury to Saturn, Sun to Pluto, asteroid belt to the Sun, or asteroid belt to the Betelgeuse star? The answer is D. Asteroid belt to the Betelgeuse star. Did you get all the answers correct so far? Good job. Now let's look at question number 4. What do we use astronomical units to measure? A. Distances in our solar system. B. How far our solar system is from others in our galaxy. C. Distance between Milky Way to its closest galaxy. Or D. The distances between galaxies. Correct. The answer is A. Distances in our solar system. Question number 5. A spacecraft travels at a speed of 100,000 kilometers per hour for 900 hours. Calculate the total distance traveled by the spacecraft in AU. Is it 6 AU, 0.9 AU, 9 AU, or 0.6 AU? Pause the video and calculate. Are you done? What is the answer? Yes, the answer is D. 0.6 AU. This is because the formula to calculate distance is speed multiplied by time. So first, multiply 100,000 kilometers with 900 hours. The distance is equal to 90 million kilometers. Now convert kilometers to AU. Divide the distance in kilometers by 1.5 times 10 to the power of 8. The final answer is 0.6 AU. In conclusion, the distance between planets can be represented easily with astronomical units. And the distance between stars can be represented easily with light years. Alright, that is all for today. Bye!
Thank you for watching and don't forget to like and subscribe.